Assalamu alaikum students. Today is our new lecture and the topic name is different from the rest of the topics we have studied before. The topic name is Laplace transform. Today we will study what is a Laplace transform. The basic formula for the Laplace transform is basically it has two kinds of functions. One is an input function, and the input function is t. F of t is the input function, and this operator, Laplace operator, L of f of t, then the function is transformed into the another function, and that is f of s. So now your variables are transformed from t to f of s. Now that is your output. Formula for the Laplace transform is f of s equals to, and the operator has the symbol this Laplace. L is for Laplace and this is the basic symbol L of f of t, and we write it in curly brackets, is equal to integral 0 to infinity e to the power minus s into t into f of t dt. Now you can see that the input function is in the form of this t function, and we multiply it with this function, that is e to the power minus st. In every formula, in every definition of Laplace transform, you have to apply the input function with this e to the power minus s into t, and we integrate it along within the limits of integration 0 to infinity with respect to t, and the resulting function will be in the form of s. So t variable is transformed in the form of f of s. So this is all about Laplace. So first example is, if you apply this Laplace transform or Laplace operator to a very basic function, we start from the basic f of t and e to the power at. E to the power at is the input function, and we have to find the Laplace transform. The question will be that find the Laplace transform of this function. So what we do just apply the definition or just this formula, and that will be f of s. Solution will be f of s equals to Laplace transform, and here the function is e to the power a into t. So integral 0 to infinity e to the power minus st, and instead of f of t we have to write it e to the power a into t dt. So bases are same, we can see that, and powers are added for this. So powers are added, and that becomes e to the st plus a into t into dt, and in that the same powers, t is the common variable here. So this integrand becomes e to the power minus s plus a into t into dt, or you can also say this as 0 to infinity e to the power a minus s into t dt. Now e has some power, and that is a minus s. A is also a constant, s is also a constant quantity, and t is the variable. So anything e to the power some constant into t means it can be integrated within this limits of integration, and it becomes it can be integrated. So our integral will become, the integral is e to the power a minus s into t. So in the exponential functions and in the trigonometric functions, you have to divide the constant, and in the integral, and in the derivative you have to multiply those constants. So here we have to divide those constants, and we apply this limits of integration, upper limit minus lower limit. So what does it become? We have to apply it along with the t. So it doesn't affect in this constant, and the constant is a minus s, and the limits are just applied to this. One more thing is that we don't want to apply this infinity symbol directly to make it undefined. So we do some kind of mathematical techniques, and that is we transform this in this function in denominator. So in denominator, when it is transformed and when the infinity is applied, then e to the power infinity becomes infinity and 1 by infinity becomes 0. So that is the very smart technique. So what we have to do, we use this, we transform this in this form, we transform it in the denominator, and that is 1 by e to the power, if I take it a minus s, then if it is transformed into denominator, it becomes minus a minus s into t, and then limits are applied. Now I apply this limit. So one more step is, if I take it as I multiply negative sign as in these two terms, it becomes s minus a. So 1 over e to the power s minus a into, and when I apply this, it becomes 1 over a minus s, 1 over e to the power s minus a into infinity becomes infinity, upper limit, minus lower limit, e to the power s minus a into 0 becomes 0, so 1 over this. So 1 by e to the power infinity becomes 1 over a minus s over a minus s, 1 by infinity, and 1 over e to the power 0 becomes 1. So this 1 by infinity is 0 and this is 1. So when it is multiplied, 1 by 1 is minus 1. So I substitute it directly. So minus 1 by, it becomes minus 1 by a minus s, and when it is multiplied term by term, it becomes 1 over minus s becomes plus s minus a. So that is the answer for the Laplace transform of e to the power a into t. So we have derived this formula that if we have the exponential function e to the power a t 1 over s minus a. Now you can see that the t variable is transformed into the s variable, and also if instead of a we have some functions like if we have some functions like e to the power 3 into t, then you can just replace this instead of a, and that is 1 over s minus 3. And if you have e to the power 7 into t, any kind of constant, it can be a rational number, it can be an irrational number, it can be any constant. So it becomes 1 over s minus 7, and if you have a negative number like e to the power minus 7 into t, then it becomes 1 over s minus 7, and that becomes 1 over s plus 7. So that this is all about our Laplace operator, and we have to go through each and every step, and the main important thing is the limits of integration are very important. So check out the next video.